Welcome back. Alright, continuing the SQL 50 series, we will now be beginning with advanced SQL, no, advanced selects and joins. So far we have completed 1, 2, 3, 4, and now we are here. Advanced selects and joins, beginning with the number of employees which report to each employee. Let's begin. Alright, so we have one table. Employee ID is a column with unique values for this table, so it can be essentially our primary key. This table contains information about the employees and the ID of the manager they report to. Some employees do not report to anyone. Okay, in which case reports to is null. For this problem, we will consider anyone a manager who has at least one employee who is reporting to them. We have to write a solution to report the IDs and the name of all managers and the number of employees who report directly to them, and the average age of the reports rounded to the nearest integer. And finally, we must ensure that our table is returned ordered by employee ID. And then we have an example down here. Okay, first of all, let me just go ahead and do that. All right. So first up, let me see, should I select a distinct? No, it is unique, so I don't think there's any need for me to select distinct. So firstly, I'll do a select. And I will have to join the table because obviously I need to create a relationship between the table, between an employee and a manager. So I will do an select e1.employee ID. I will grab, let's go e1.name. I will grab the count of e1.employee ID, and what do I need to grab it as? It is counted as reports to, so as reports to. I will then grab the rounded value of the average of, and this time, let me see, it can't be the same table. Okay, so e2.age, rounded off 0, as average age. And obviously from two tables, so from employees as E1, and then I will join itself on employees as E2, and then I will join it on E1 dot employee ID, which is equal to E2 dot reports to. And now I will hopefully successfully have a relationship between an employee and an associated manager. I'll then group by, because I have two aggregation functions on top, that being count and round, so I will group by. Let's do e1.employee ID, and finally I will do an order by e1.employee. Is it ID as well? Yeah. Let's try running that. Okay, that's wrong. We get, oh, reports count, not reports to. Alright, there we go. An accepted runtime for our test results. Let's do a submission. Every day. Alright, and we have a successful submission. A pretty decent one, very good. Let's go to the next question. Let's get rid of the solution. And here we have one table, but so much of annoying information. Okay, so we have a table called employee, 3 attributes, an employee ID of integer, a department ID of integer, and a primary flag, which is a variable char. We are then told that employee ID and department ID is a primary key. Okay, employee ID is the ID of employee. Department ID is the ID of the department to which the employee belongs. Okay. And primary key is actually an enumerable category of only types Y for yes and N is no. If the flag is Y, the department is a primary department. If not, then the department is not primary. Okay. I'm then given even more information stating that employees can belong to multiple departments. When the employee joins other departments, they need to decide which department is their primary department. Note that when an employee belongs to only one department, their primary columns is N. Okay, yeah, that makes sense. Okay. Write a solution to report all employees with their primary department. If an employee belongs to one department, return their only department, obviously, okay? And then return the table in any order. And then we have an example here with employee ID of 1, main department is 1, employee ID 4, main department is 3. Okay. What I can do is let's start with a simple one, which is select employee ID and department ID, okay, from employee. This is simple, where primary flag is equal to yes. This will only grab employee and department ID from the employee table where this primary flag value here is yes. So let's run that. Obviously, it's wrong. However, if you look at the example, you notice that we have our employee ID and our department ID. Wait, do I need to order it? Okay, no. So 2, 1, 4, and 3. So if you notice, we have 2 and 1, and we have 4 and 3, okay? So we have somewhat of a right solution. All we have to do now is this. Let's go back up here. And I will come down here and I will do this. I will do select employee ID department ID from employee. Now, I will do a group by. You may be asking again, I have no aggregate function. Why am I doing a group by? The thing is, you can also use an aggregation method or function after group by doing this. Having. And now I can do having count of department ID equal to 1. Okay, and for now I will comment this part out. Now if I run this, it's wrong again. However, this time you notice we get 1 and 1, and we get 3 and 3. So we have two parts of a solution, but we don't have the actual solution, right? However, as I said in a prior video, whenever you do a select query, you are creating a table. And we can actually join two tables. Now, not join during runtime, join after the creation of those two tables. And we can do this by using something called a union. U-N-I-O-N. And now if I union that, and if I union this, no. Okay. And now if I run it, and there we go, accepted. So we had two individual solutions, and by doing a union, we took those two solutions, made it into one, and that is our correct solution. And there we go. Next question. Triangle judgment. And let's get rid of this. Confirm. Okay. I remember this question was quite annoying when I first did it. So we have a table called triangle with three attributes, x, y, and z, all being an integer. In SQL, all three attributes for a given row will make up a primary key. We are also told each row of this table contains a length of 3 line segments. So think of a line, like if you draw a line on a piece of paper, that line obviously has some length. X, Y, and Z will represent 3 individual lengths. We need to report for every 3 line segments, so as they appear in a record, a tuple, a row, do those three lines make up a triangle? Now here's the thing, if you weren't aware of this, you obviously are going to have to do a little searching online, or if you did a maths class, it would have been, what was it called? Analytical geometry. Was it analytical geometry? Nope, it could have been analytical. What was it in high school, dude? What were you called? Was it analytical geometry? I believe so, analytical geometry. But anyway, there are things that you will learn. You will learn that given a side, so say A, B, and C, you could do the following. If A plus B was greater than C, and A plus C would be greater than B, and what is, it should be B plus C, I think. B plus C is greater than A, you can say that yes, this may just be a triangle. Following from that, if we select X, Y, Z from triangle, we need to do something. We need to figure out when this condition holds, return true basically, and when it doesn't hold, return false. Okay. And we do this, well, I chose to do it by using something called a case. And to do a case, I need to have an end there. And then I'll do a when in here. When. Let's do create a big one, and then I'll come in here and I'll do essentially A plus B, but in this case it's going to be X plus Y greater than Z. And X plus Z greater than Y. And Y plus Z, it'll be Y plus Z, would be Y plus Z, A, B, C. Yeah, okay, so Y plus Z greater than X. In that case, if all three of these conditions hold, in that case, then I will say yes. But if these three conditions do not hold, else I'll say no. And I'll end as triangle. And I know this because if I look at the output, I need to run XYZ, I need to return XYZ, and an attribute called triangle, which is a boolean of no or yes, where no represents false and yes represents true. Now hopefully if I try to submit this, if those three conditions hold, it should work. If I remember my formulas correctly. I actually have an error in my syntax, okay. And I know what that error is. I just caught myself out. Remember, I said I'm returning another attribute, right? Another column. Now, obviously, I can't just do that. I have to have the comma there to say that what I'm calling next is a column. And actually, there we go. I remember my formulas correctly. No, yes, okay. Now submit that. And there we go. Okay. Let's go on to the next one. I will get rid of this. Okay. We have one table called logs, only two attributes, an ID and a number, an integer and a variable char respectively. We need to find all numbers that appear at least 3 times consecutively, which means one after another at least 3 times. And we must return the table in any order, and then we have an example. We come down here and we can find it. we notice that the only number that appears 3 times consecutively is 1. Let's see, where do you appear? Here we go. Okay, 1, 1, 1. The ID of 1 is 1, the ID of 2 is 1, and the ID of 3 is also 1. So that is the only one that matches our conditions to be returned. So first of all, we notice that we have non-unique values, so we'll obviously need to grab a distinct function to wrap our values. And then what we have to do after that is actually very simple, and I'll show you. Let's do a select distinct, and I'll do L1.nums as consecutive nums, okay, from logs as L1. Now this will grab every number in L1, right? Every number from the logs table. But what if I did this? What if I did a join logs as L2 on L1.id is equal to L2.id minus 1. So essentially, it's going to look at this table and say, okay, L1's ID is 1. L2's ID is 1 minus 1, 0. Do we count that? No. Well, what about the next time? L1 ID is 2. L2 ID is 2 minus 1, which is 1. Well, yeah, let's match that. But then it's not going to work. We need to add one more thing. We need to say where, once we have an ID match, we need to say L1.num is equal to L2.num. Okay? This will ensure that yes, we join correctly, but we only select the rows where L1.num is also equal to L2.num. But we aren't done yet. We need to do another join. We need to join logs as L3 this time on L1.id, which is equal to L3.id, and this time we minus 2 of the value. And obviously, because you did that, we need to add an AND here and say that L2.num is equal to L3.num. And now when we try this, unknown column L1.nums, or you should just be num, right? Yeah. And there we go. Let's submit it. All right, let's go to the next question. And I will get rid of this. Okay, product price at a given date. We have one table called products. We are told that product ID and change date is the primary key for this table. Each row of this table indicates that some price of some product was changed to a new price at some date. We need to find or write a solution to find all prices of all products on the 29th, 8th, 16th. And we must assume the price of all products before change is 10. We can return the result table in any order. And then we have our products table and we have the output. Let's just look at product ID of 2 with the price of 50. So it would have been here. Does it 2019, 816? Okay, yeah. So we're not going to look at this date because this is after the 16th. But before the 16th, we'll use this date. Okay, cool. If you notice up here, I was trying a bunch of things when I initially solved it. But anyway, you can read through that if you want. What we can do is select distinct. Wait, do I need distinct? Yeah, I need it because if you notice on this table, we have a bunch of recurring values. So distinct product ID. Or I'll just grab 10 as price. From the products table, obviously I only have one table. But I only want to do it where product ID, and now I'll use a subquery, not in, and I'll do this. Select distinct product ID from products where change date is less than or equal to, and then I'll grab that date from up here. Okay. Now if I just run this part, it's wrong. I only have 3 and 10, which is actually what it should be, right? We have 1 record matching, which is cool because we only selecting the product or 10 as price from dates prior to the date, the required date. And then I'll do this. I'll come down here and I'll do select distinct product ID and new price as price. Okay, from products where product ID and change date in, and again I'll use a subquery. I will do a select, what will it have to be product ID, right? I'll have to do that, and then it'll be max change date, so I get the most recent date. And then I'll filter it, so from products where change date, so grab the max change date, but only when the date is less than or equal to that. And then I'll obviously have to do a group by, so I have every individual product's most recent date. And for now, I will comment this part out, and I'll run that bottom query. It's wrong, but if you notice, we get 2 and 50, 1 and 35, which is 2 and 50, and 1 and 35. Okay. So we are on the right track, and now all we have to do is uncomment that out and do a union. And there we go. 2 solution tables combined into one to give us our final correct answer. And there we go. Next one. Last person to fit in the bus. This was a fun question, okay. We have one table called Q, a table called Q, funny. Person ID contains unique values, that's good. This table has information about all people waiting for a bus. The person ID and turn columns will contain all numbers from 1 to n, where n is the number of rows in the table. So say number of rows was 5, then we will go from 1 to 5. Turn determines the order of which people will board the bus, where turn 1 denotes the first person and turn n denotes the last person. So essentially it follows a queue structure of first in, first out. And weight is the weight of the person in kilograms. We are also told that there is a queue of people waiting to board a bus. However, the bus has a weight limit of 1,000 kilograms. So obviously some people cannot board. Write a solution to find the person's name of the last person that can fit on the bus without exceeding the weight limit. The test cases are generated such that the first person will obviously not weigh 1,000 kilos. And then we have an example down here. We see that John Cena, okay, so let's look at it. Person 1, person ID and turn columns. Turn determines, okay, right. So turn 1, Alice is fine. Turn 2, Alex is fine. Turn 3 is John Cena. 400 plus 300 is 750 plus 250 is over 1,000. Therefore, John Cena is the reason that the bus weight increases to beyond 1,000 kilos. Therefore, he is the one who cannot board the bus. Okay. Let's think. We need to grab consecutive turns. So let's do a select from Q as Q1. Join Q as Q2. On Q1.turn is, we'll do a non-equality join. It's greater or equal to Q2.turn. Okay. We'll do a group by Q1.turn having sum. This is important. Having sum of Q2.weight being less than or equal to 1,000. Okay. And we'll finally do an order by sum Q2.weight descending. And for now, I'll end it there. Obviously, I'll come up at the top and I'll do Q1.person name. Let me run this. Let's come down here. We have John Cena, Alex, and Alice. Let's also add their weight. Q1 dot weight. And there we go. If you would notice, this table is in descending order, therefore starting at the highest value where 400, 350, and 250 obviously exceeds 1,000. So what we can do to filter this table to get the correct answer is simply do this. Limit 1, and we'll only grab the first record. And done. Submit that. And we have solved it. The next and last question, I believe, for advanced selects and joins. Quite a hefty one, but in reality, it's not that difficult. Okay. We have an accounts table with only two attributes, account ID and income. Account ID is a primary key. Okay. Now, we need to write a solution to calculate the number of bank accounts for each sale category. We have three sale categories. Low salary is any salary less than $2,000, $20,000. Average salary is in the inclusive range of $20,000 to $50,000. So it's including, okay? So we include our start point and our end point. And finally, high salary is all the salaries greater than $50,000. The result table must contain all three categories. If there is no account in a given category, we just return 0. And we can return the table in any order. It seems like a lot, but in reality, it's actually only 3 selects. So first of all, let's select low salary as category. And then I'll do this. I'll do a count of account ID, because that's what we're doing, right? We are trying to figure out how many accounts match up to being a low salary account. As accounts count, and the only reason I know this is because of down here, which I remember from earlier. From accounts, but I only want to do it where income is strictly less than 20,000. So let's figure out what we're doing. I'm going to create a new attribute called low salary as category, okay? And I will, wait a minute. Okay, no, it's right, okay, yeah. So I'll create a new row called low salary, and the attribute name will be called category. I will then count all the account IDs in the table, and I'll give it the alias of accounts count. However, I'm only going to do that where the income is strictly less than 20,000. And if I run this, it's obviously wrong. I have low salary and I have 1, okay? But I'm missing high salary and average salary. Now, instead of doing joins and creating a very long mess, why don't we just repeat this for the other 2 account types? So what if I just select this, I copy it, I come down here and I paste it. And then instead of low salary, I do average. If I could spell average salary, right? Average salary, and everything stays the same except this, where income is between, including 20,000 and 50,000. Okay, and if I just do a union here, if I run this, it's again wrong, but if you notice, I now have average salary 0, which is actually what I want, okay? So if we do it one more time, instead of low salary, I make it high salary, and everything stays the same except this, where now it must be strictly over 50,000, and again, I'll do a union. If I run that, and there we go. 3 very simple queries that makes a question seem more difficult than it is. We will only count the account ID when we match up this sort of having. I forget, how can I describe it? We only count an account that has a strict rule of having income less than 20,000. And we repeat this 2 more times, one for the average salary, which is between 2 values, and one finally for the high salary, which is greater than some value, in this case 50,000. Now if we submit this, we get a correct solution. Now if we go on to the next question, we will stop here because this ends at, or I should say it begins with the next table of questions, which are all subqueries. Okay, we are done for today.